we go.
I know how to do this.
No, it's not.
No, it's pretty easy. Okay, first thing in our foldables, let's write. Open the first page. We're going to write when SciNote is used. So let's write this down. You can write the word scientific notation, or you can just kind of call it SciNote. That's short. It is used, like we've already talked about, to write very large or very small numbers.
We're gonna take up all these pages. We're gonna take up all these pages.
Eventually, because we have to eventually turn into multiplying and dividing in scientific notation, and that's where it gets a little uglier. But for today, we're gonna keep it pretty simple. Here is. Let's take a look at this. This is a number written using scientific notation, and let's just kind of break that down. This is 4 2/10 times 10 to the third power, written in scientific notation. You've probably seen this before. Notice that this number, the first number here, 4.2, it has to be a number between 1 and 10. If it's over 10, it's not in scientific notation. If it's under 1, it's not in scientific notation. So this number needs to be a number in between 1 and 10. Okay? This little number here, your exponent, bless you, tells you how many places, how many places you move the decimal. And I'm going to write a little text. Sorry. You move the decimal to the right or left. What makes the difference in the right or the left? Does anybody know?
You both apply it right into
Okay, what about in terms of the positive versus the negative exponent? Because sometimes, this right here is probably going to be new for you. Sometimes the exponent is negative, right? We saw that last week.
I just didn't say anything.
The exponent can be negative. Okay? Move the decimal. Decimal to the right or to the left. All right, here's how you know which way to move it. We'll put these little asterisks, and I have to remind myself often, okay? If the exponent, if the exponent is positive, the original number is large. A very large number. Like up here, this would be 4, 2, 0, 0. Okay. I would move my decimal 3 places, and I would end up having to move it to the right because I'm multiplying, okay, by 10 cubed. So it would be a very large number. If you have a negative exponent, the original number is small. For example, if my above problem had been 4.2 times 10 to the negative third, I'm going to move my decimal to the left 3 spots, okay, because of the 3. So I would move it to the left 3 places. Let me write it right here and move it 3 spots. 1, 2, 3. Put a decimal. So it would end up being decimal 0042. Does anybody know how to read that using place value? 42 tenths, hundredths, thousandths, 10 thousandths. So that would be 42 10,000ths. And so it's a very small number. Jeez. I knew it was going to be small because it had a negative exponent. So that should be your clue. As soon as you see the exponent, if it's positive, it's a big number. If it's negative, it's a small number. Okay? So that should be very easy for you to spot. Now I'm going to have to move over because I'm going to start our steps in our process, okay? We're going to be moving from standard form to SciNote. and we will go through just a couple steps. 2 little steps is all you have to do. Step 1. Move the decimal. To make a number.
Crap, we actually have a test on this in week 2.
Yep. To make a number between. What does the number have to be between over here on the left that we just said? Yes, between 1 and 10. That's your first step. Move the decimal to make the number you're dealing with a number between 1 and 10. Second step, count the number of spaces you moved your decimal. And what does that become? Does anybody know?
Exponent.
Yeah, perfect. You move the decimal, and I'm going to put dot, dot, dot. That becomes the exponent. Okay, so this really isn't as bad as what some of us may believe. Let's look at this example. If I have this, can anybody even tell me, read this number for me?
Supposed to raise your hands, people.
Go ahead, Jonathan Gregory.
2 billion and 72 million, or 2.72 million.
Okay.
2,720,000,000.
I agree with that. 2,720 million. So, do you see why scientists sometimes don't want to say these words? Okay.
But isn't it like you don't say ants? Well, somebody should have that much money.
200 billion, 720 million, yeah, when you see the word, yeah, decimals typically. Or some people, like Jonathan just said, 2.72 billion, okay? A lot of times they will say that. So let's, first of all, let's forget about this number and how to say it. Let's write it in sign note. So where's the decimal if you don't see one? It's always at the end right now. It's always at the end like a period in a sentence, okay? And then our step 1 says move the decimal to make it a number between 1 and 10. I'm going to take it, I'm going to move it right there.
Oh, right there, where the 2?
That's where you move it, in between your first 2 good digits, or non-zero digits. So this becomes 2.72. Do you all agree with that?
I did.
All the zeros go away. We've moved our decimal. We're keeping only the good digits, or the non-zero digits. Okay, they're not included in your number here.
They're pure.
This is going to be times 10. Now, how did we get our power?
Count the zeros.
Count, not just the zeros, but the
Places
spaces you move the decimal. So from here, we would have moved it 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, would this be a positive 9 or a negative 9?
Negative. Moved it back.
Doesn't matter about that. We're fixing it in sign note. Let's go back and look.
It's a big number, so.
It's a large number. Large numbers have what type of exponents?
Positive.
They have positive. So a large number to begin with, you know it's going to have a positive exponent. Let's try another. I'm going to give you one that may be not a large number to start with. So put your decimal first. Put your 3 zeros. 3 more zeros. 2 more zeros.
How many zeros we got?
And a 1, 2, 3. So set of 3, 2, and then 1, 2, 3. Now look at that. First of all, as soon as you see it, is it a big number or a small number?
Small. No, small.
It's small because it's decimal, so it's very, very small. It's microscopic, as we heard earlier. So what kind of exponent are you going to have with a very small number? Yes, small numbers get negative exponents. So I can fix this. I know it's going to be times 10 to the negative something. That's all I know so far. Let's go through our steps. Step 1 says make this a number, move the decimal to make it a number between 1 and 10. So I'm going to take it, move it, move it, move it. Here's where I should move it. Why?
Because the 2 best numbers.
It's between your 2 non-zero numbers, but 1.23, think in terms of money, it's $1.23. Is that in between $1 and $10? Yes. If I had moved it over here, it would have been 12.3, and that would have been too large. It would not have fallen between my rule of 1 and 10.
How would you even?
This is easy, boss.
Okay, So this is 1.23 times 10 to the negative. Let's see how many spots we moved it. 3, 4, 5, 6, 7, 8. I moved it 9.
Son of a monkey.
So 1.23 times 10 to the negative 9 on that one. Let's try some more examples.